What's up guys, Finn here. So I've been burnt out working on this game engine recently and have decided to pick up Unity again. However, every first person character controller video I've seen online has been above 20 minutes and contains this one annoying bug which requires a whole article to fix. So I've made this video to help. The first step is to create a capsule as a placeholder for the player, then we'll attach a Rigidbody component to this which will be responsible for the physics. Make sure to select Interpolate and freeze rotation should be checked for all axes, and reset the position to the center of the map. Then add a camera so we can see the scene. Reset this to 0 and 1 on the y-axis and make sure the main camera tag is selected. Create a script, I'm going to call this one camera tutorial, and drag it onto the player we just created. Once inside the IDE, remove the auto-generated comments and make some room for some variables. The first two will be for the yaw and the pitch for keeping track of the mouse movements. Also add a variable to reference the Rigidbody encode. The final variables will be for the walk speed and the sensitivity. I've written serialized field, but you don't have to because public variables are serialized by default. The last piece of code for setup will be for locking the cursor to the center of the screen and getting a reference to the Rigidbody component. We will now move on to the looking function. Make a new function and pop it in the update function. The mouse y-axis will generate a positive float or moving the mouse up, but in-game it's inverted, so we subtract it from the pitch. Also clamp the value between -90 and 90 to prevent your player from breaking their neck. The yaw is normal, so simply add it to the X rotation, remembering to multiply both pitch and yaw by sensitivity. Finally, set the camera's rotation to the pitch and the yaw by using quaternion Euler, as the camera's rotation is stored as a quaternion. As you can see, we've got a brilliant looking script. For the movement part, we will create a new function and put it inside the fixed update function, as it is frame rate independent and used for physics calculations. This ensures movement stays consistent frame to frame. Create a new vector to store the horizontal and vertical axes. These are a float from -1 to 1, which will change with the corresponding movement keys. Notice I don't use raw axis, so Unity can automatically apply smoothing. Multiply these by the walk speed. The forward vector will be calculated from the camera's right vector, so when you look up you don't start flying. This also stops the jittery camera shown at the beginning by not using the Rigidbody forward vector, as it is not updated often enough and out of sync with the camera. The final vector is for the wish direction, which is a combination of the forward vector and the vertical axis for pressing W and S, and the right vector and the horizontal axis for pressing A and D. Also add the camera's velocity in the y-axis to the end. Finally set the Rigidbody's velocity to the wish direction. The last two lines of code will be for jumping. This will sort of bunny hop while space is being pressed. We'll check if the player is on the ground before we jump by drawing a ray cast from the bottom of the player to the floor, making sure it's a tiny bit above the floor so it doesn't clip through. And finally set the Rigidbody velocity to its current velocity and 5 in the y-axis. You can add your own checks so it doesn't continuously jump, but this tutorial is sort of bare bones. So that was my take on the Rigidbody camera controller. Subscribe because more videos will be coming soon related to programming or other Unity tutorials, and leave a comment in case anything didn't work or you have any suggestions for me, and make sure to like the video, it will really help with the algorithm. Thank you.